Hey everyone, welcome back to the channel. Today, we're going to tackle a very common enterprise requirement, reading data from an Excel file and inserting it into a database using Spring Batch. Spring Batch provides fantastic out-of-the-box support for CSVs and XML files, but when it comes to Excel, we actually need to write a little custom logic. In this video, I'll walk you through building a custom item reader using Apache POI, and we'll write that data straight into an Oracle database. Let's jump right in. I'm over at the Spring Initializr. We're building a Maven project using Java 21 and Spring Boot version 4.1.0. I'll name the artifact Spring Batch import Excel file. For our dependencies, we need a few things. Spring Batch for our processing framework. Spring Data JPA to interact with the database. Oracle driver because we are connecting to an Oracle database today. And finally, Lombok to save us from writing boilerplate code. I'll generate this, extract it, and open it up in the IDE. Before we write any Java code, we need one more dependency that isn't on the Initializr. Because we are parsing Excel files, we need Apache POI. I'm dropping in the POI artifact, version 5.5.1. This is the standard library in the Java ecosystem for working with Microsoft Office documents. Let's load those Maven changes. Next, let's configure our database connection in application.properties. I'm naming the application and setting up the standard Oracle JDBC URL. I'm connecting to a local Oracle instance on my machine using the demo user. If you are using MySQL or PostgreSQL, you just swap out your URL and driver class name here. Before we start writing our Java entity, let's take a quick look at the source file we are importing so we know exactly what we need to map. As you can see down here, we have a sheet specifically named Products. Inside, we have three columns, name in column A, price in column B, and quantity in column C. Notice that we also have a header row on row 1. We'll need to remember to skip that in our Java code so we don't try to parse the word price as a number. Now that we know our data structure, let's go build our model. I'll create a model package and a product class. We'll annotate this with @entity and @table, name equals products. I'll also add our Lombok annotations @data, @noargs constructor, and @allargs constructor. For the primary key, since we're using Oracle, I'm setting up a sequence generator mapped to products_seq. Then we add our fields matching the Excel sheet, string name, double price, and integer quantity. To handle the database saves, we just need a standard JPA repository. Inside a new repository package, I'll create product repository as an interface extending JPA repository. We'll pass in our product entity and long for the ID type. That's all the database setup we need. Now comes the most interesting part of today's video. Spring Batch already provides readers for CSV files. But it doesn't provide a built-in Excel reader. So we'll create our own custom item reader. I'll create a class named xlsx. It implements ItemReader product. Every custom reader must implement the read method. Spring Batch keeps calling this method repeatedly. Every call should return one product object. When there are no more records, it should return null. Returning null tells Spring Batch that reading has completed. Let's create a few member variables. First, we need an iterator row. We'll use this to move through each row of the Excel sheet. Next, we'll keep a workbook reference. Once Apache POI opens the Excel file, it creates a workbook object that represents the entire Excel document in memory. We'll also store the input stream because we'll need to close it after processing is complete. Next, we need a resource object. This represents the Excel file itself. Notice that we're not creating or opening the file inside this reader. Instead, we'll pass the resource from our Spring Batch configuration class, where we'll configure products.xlsx as the input file. Finally, I'll create a boolean called isInitialized. This ensures that the Excel file is opened only once. Without this check, every call to read would reopen the Excel file from the beginning, and we'd end up reading the same rows repeatedly. Now let's create the constructor. The constructor simply accepts a resource object and stores it in our instance variable. We'll pass this resource from our Spring Batch configuration class later, where we'll specify the Excel file we want to read. Next we will annotate this class with @stepScope. @stepScope tells Spring to create a new instance of this reader every time the batch step executes. That's important because this reader maintains state, such as the current row, the workbook, and whether it has already been initialized. If the same reader instance were reused across executions, that state could lead to unexpected behavior. Another advantage is that @stepScope allows us to inject job parameters at runtime. For example, instead of hard-coding products.xlsx, we could pass the Excel file path as a job parameter and process different files without changing this class. Now let's implement the most important method of our reader, the read method. As we discussed earlier, Spring Batch keeps calling this method repeatedly until it receives null. Every time this method is called, it should return exactly one product object. Let's start with the first condition. Here we're checking whether the reader has already been initialized. If not, we call InitReader. Don't worry about its implementation just yet. We'll write that method in a moment. For now, just remember that its job is to prepare everything required before we start reading data. It opens the Excel file, creates the workbook, gets the required sheet, and prepares the row iterator. Once the initialization is complete, isInitialized becomes true, so this block is skipped for all subsequent calls. Next, we check whether another row is available. If there are no more rows, it means we've reached the end of the Excel file. Before stopping, we call closeResources. We'll implement that method shortly. Its responsibility is simply to close the workbook and the input stream so that we don't leave any resources open. Finally, we return null. Returning null is very important because this is how every item reader tells Spring Batch that there are no more records to process. Once Spring Batch receives null, it knows that reading has completed and the step can finish successfully. If another row is available, we move the iterator to the next row. At this point, the row variable represents one complete row from our Excel sheet. Next, we create a new product object. Our goal is to convert the current Excel row into this Java object. Later, Spring Batch will pass this object to the writer so it can be stored in the database. Now let's populate the product object. The first column contains the product name. The second column contains the product price. And the third column contains the quantity. Since price and quantity are numeric cells, we're using getNumericCellValue. Notice that getNumericCellValue always returns a double. Our quantity field is an integer, so we're explicitly casting the value to an integer before storing it. Finally, we return the populated product object. Spring Batch receives this object and adds it to the current chunk. Since our step doesn't have an item processor, the object will later be sent directly to the ItemWriter. After returning this product, Spring Batch calls the read method again to fetch the next record. This process continues until read eventually returns null. Before moving on, let's quickly understand how Spring Batch executes this method. Suppose our Excel file contains 3 records. Spring Batch calls read for the first time and receives the first product. It immediately calls read again and receives the second product. Then it calls read a third time and receives the third product. Finally, it calls read one more time. Since there are no more rows, we return null. Returning null tells Spring Batch that reading has finished. This is the standard contract followed by every ItemReader implementation in Spring Batch. Now let's implement the InitReader method that we called earlier. This method is responsible for preparing everything before we start reading the Excel data. First, we obtain an input stream from the resource. Remember, the resource represents our Excel file. The input stream allows us to actually read the contents of that file. Next, Apache POI reads the Excel file and creates a workbook object. You can think of a workbook as the in-memory representation of the entire Excel document. If the Excel file contains multiple sheets, they'll all be available through this workbook. Next, we retrieve the sheet named Products. This is the sheet that contains the data we want to import. It's always a good practice to validate the sheet. If someone accidentally renames or removes the sheet, we want to fail immediately with a meaningful error message instead of processing incorrect data. Now we create an iterator for all the rows in this sheet. This iterator allows us to move through one row at a time. Notice that the first row in our Excel file contains the column headers. We don't want to insert values like name, price, and quantity into the database. So we simply move the iterator once to skip the header row. From this point onward, every call to next returns actual product data. Finally, we mark the reader as initialized. The next time Spring Batch calls the read method, this initialization logic will be skipped. Instead, we'll continue reading from the same workbook and the current position in the iterator. Finally, let's implement the closeResources method that we called when there were no more rows left to read. First, we close the workbook. Closing the workbook releases the resources used by Apache POI after processing is complete. Next, we close the input stream. Whenever we open external resources like files or streams, it's a good practice to close them once we're done. This helps prevent resource leaks and keeps the application efficient. Since closing these resources can throw an I/O exception, we handle it here. In this example, we're wrapping it inside a runtime exception. In production applications, you may choose a different exception handling strategy depending on your project's requirements. Now that our custom reader is ready, let's configure Spring Batch. I'll create a class called BatchConfig. This class will contain all the Spring Batch beans required to execute our job. We'll configure the reader, the writer, the step, and finally the job. Let's start with the reader. Here we're creating the XlsItemReader bean. Notice that we're passing a class path resource. This tells Spring to look for the Excel file inside the application's class path. And we will place products.xlsx inside the resources folder, so Spring can easily locate it. Remember earlier when our reader accepted a resource in its constructor? This is exactly where we're providing that resource. If tomorrow you want to process another Excel file, you can simply change the resource or even pass it as a job parameter. Now let's configure the writer. The responsibility of an item writer is to store the data after it has been read. Since we're saving data into a database, Spring Batch provides a convenient implementation called RepositoryItemWriter. Instead of creating the writer manually, Spring provides a builder that makes the configuration much cleaner and easier to read. Here we're providing our product repository. This is the same repository we created earlier by extending JPA repository. Next, we specify which repository method should be called. In our case, we're using the save method. That means whenever Spring Batch sends a product to the writer, it internally executes product repository.save product. We don't have to write any insert SQL ourselves. Finally, we build the writer bean. Our writer is now ready to persist product entities into Oracle database. Let's quickly understand what we've built so far. Our reader reads one row from the Excel file and converts it into a product object. The writer receives those product objects and stores them in the database. The step, which we'll configure next, is responsible for connecting these two components together. Now let's configure the step. If you're new to Spring Batch, you can think of a step as one unit of work. A job can contain one or more steps. In our example, we only have a single step that reads the Excel file and stores the data into the database. First, we create a step builder. We provide the step name along with the job repository. The job repository stores metadata about every job and step execution, such as whether the execution completed successfully or failed. Next, we configure chunk processing. This is one of the most important features of Spring Batch. Here we've specified a chunk size of 10. That means Spring Batch reads 10 product objects before calling the writer. After all 10 records are written successfully, the transaction is committed. Then Spring Batch starts processing the next chunk. Chunk processing improves both performance and transaction management. Since we're writing to a database, Spring Batch needs a transaction manager. It ensures that every chunk is processed within a transaction. If an error occurs while writing a chunk, the transaction can be rolled back, preventing partial data from being stored. Here we're connecting our custom XlsItemReader. This is the same reader we built earlier. Next, we connect the writer. Notice that we haven't configured an item processor. That's perfectly valid. Spring Batch allows us to skip the processor when no business logic or transformation is required. The data will flow directly from the reader to the writer. Finally, we build the step. Our step is now fully configured. Let's visualize the complete data flow. Our XlsItemReader reads one row from the Excel file. It converts that row into a product object. Since we don't have a processor, the product goes directly to the RepositoryItemWriter. The writer then calls the repository's save method and stores the record in Oracle database. Spring Batch repeats this entire process until the reader returns null. The last piece of our batch configuration is the job. A job represents the complete batch process. It defines which steps should be executed and in what order. Here we're creating a new job using the job builder. Since our application has only one step, we simply start the job with that step. In larger applications, you can chain multiple steps together. For example, one step could validate data, another could process it, and a third could generate reports or send notifications. Finally, we build the job. Our Spring Batch configuration is now complete. Everything is now ready. Let's run the application and see Spring Batch in action. Once the application is fully initialized, Spring Batch automatically launches our job. Here you can see that our import product job has started execution. Inside this job, Spring Batch begins executing the import Excel step that we configured earlier. During this step, our custom XlsItemReader starts reading the Excel file one row at a time. Each row is converted into a product object and passed directly to the RepositoryItemWriter. The writer then saves those records into our Oracle database. Once all the rows have been processed, the reader returns null, indicating that there are no more records to read. Spring Batch then completes the step successfully. Finally, the job finishes with the completed status, which we can see here in the logs. Now let's verify that the data has actually been inserted into the database. And here we can see all the records from our Excel file have been successfully imported into the products table. That's it for today's video. I hope this tutorial helped you understand how to import Excel data using Spring Batch. In the upcoming videos, we'll take this project a step further. Instead of hard-coding the Excel file inside our configuration, we'll learn how to pass the file dynamically at runtime using job parameters. We'll also look at how to read and process multiple Excel files in a single batch job, which is a common requirement in real-world applications. If you'd like the complete source code for this project, along with detailed Spring Batch articles and other Spring Boot tutorials, make sure to visit springjavalab.com. I'll leave the link in the description below. Since this is still a new channel, your support really makes a difference. If you found this video helpful, please consider subscribing and turning on notifications so you don't miss the upcoming Spring Batch videos. Also, let me know in the comments what Spring Batch topic you'd like me to cover next. I read every comment, and your suggestions help me decide what to build next. Thanks for watching, and I'll see you in the next video.